Millions of people, adults as well as young children and babies, suffer from heartburn and regurgitation caused by the reflux of gastric contents into the esophagus. We're talking about gastroesophageal reflux disease, generally abbreviated as GERD. It can sometimes be difficult to know whether symptoms are due to GERD or something else. A 24-hour Impedance Ph examination with the Ohmega recorder can be very useful to diagnose this problem. To understand what we are talking about, you first have to pick up some in-depth information about pH measurement, impedance measurement, and reflux monitoring. Until recently, reflux was detected by measuring the pH in the esophagus. When acidic material enters the esophagus, the pH drops. With pH monitoring, the proximal extent of gastric content cannot be detected. pH studies can only detect acidic reflux episodes. Under acid secretion inhibiting medication, most of the reflux episodes are weakly acidic. However, these reflux episodes can also cause symptoms and cannot be detected in pH studies. This was until recently. Now we have a new technique which combines pH and impedance measurements. This new technique will be explained. To improve the measurement technique, we add rings to the catheter. Between the two rings, the impedance is measured. In rest, the measured impedance reflects the impedance of the esophageal mucosa. Let's have a look at channel 1. What happens with the impedance when liquid is swallowed? This is the baseline level of the impedance signal, caused by the esophageal mucosa. When a liquid bolus touches both rings, the impedance drops. When there is no more liquid on channel 1, the value of the impedance signal will return to the baseline. The standard catheter, which is used to measure impedance, has 6 channels. Signals are measured between the rings on the catheter. In this example, the impedance channels are named Z. We will now show you what happens on all 6 impedance channels when liquid is swallowed. First, the liquid bolus will pass channel 1. The impedance drops on that channel. The liquid bolus moves and reaches channel 2. The signal of channel 1 returns to the baseline, and on channel 2, the impedance drops. The liquid bolus moves down and reaches channel 3. Impedance drops on this channel. As the liquid bolus moves farther down, it will be detected on the other channels. The bolus entry and exit in each segment is displayed by the 2 lines. We have explained the impedance pattern of a liquid swallow. Now we will explain the impedance pattern of a reflux episode. Reflux means that gastric contents move up into the esophagus. As soon as it reaches channel 6, the impedance drops. As the refluxed bolus of gastric contents is moving farther up, channel 5 is reached, and the impedance level of that channel also drops. This continues until the reflux bolus reaches its highest proximal extent. This example shows the proximal extent up to the top impedance channel. On every channel, the impedance dropped, indicating refluxed bolus. The refluxed contents are removed from the esophagus by a peristaltic contraction. This is called clearance. A typical example of a graph looks like this. The arrow shows the entrance of the refluxant in the esophagus. The second arrow shows clearance of the refluxant. This is a pyramid shape. In this example, the reflux does not reach the proximal esophagus. This is shown as a flat pyramid. We will now explain the impedance pattern of a gaseous reflux. Air is released from the stomach. This is a belch. When air touches two rings of a channel, the impedance increases. When the air moves farther up, the impedance on the channel above will increase. At the distal channel, the impedance level will return to the baseline. This continues. The entry and exit in each segment is depicted by the two lines. We have seen these three impedance patterns: a liquid swallow, a gastroesophageal reflux, and a gaseous reflux. We will continue with pH and impedance measurement. The pH is measured with the pH sensor on the catheter. When the pH value is lower than 4, this is an acidic reflux episode. When the pH stays above 4, this is a weakly acidic reflux episode. A reflux with a pH below 4 is called an acid reflux. Between 4 and 7, a weakly acidic reflux, and above 7, a weakly alkaline reflux. An impedance value below 1000 is liquid. Between 1000 and 3000, it is a baseline value, and above 5000 is air. These are estimations. This is a typical example of a swallow, recorded with impedance monitoring. The baseline impedance level is observed, followed by an increase in impedance, which is caused by swallowed air. This is followed by the decrease caused by swallowed fluids. After the passage of the fluids, there is a small increase in impedance again, caused by the contraction of the esophagus. Finally, a return to the baseline is observed. These are the impedance patterns: a swallow, a reflux episode reaching the proximal esophagus, a reflux episode with a limited proximal extent, and a gas reflux episode. The shape of the impedance pattern informs us of the proximal extent of the reflux episode. The next step will be the Impedance Ph Examination procedure.